These are a few problems from the 17.1b assignment. The first two problems I'm working out deal with if they give you a triangle, how do you find whatever trig ratio they asked you for? Number two, they give us a theta angle right here, and straight across from that, we're going to have our opposite. And of course, across from the right angle, we have our hypotenuse. And then the side that's not a hypotenuse but is touching is what we always call our adjacent. Okay. In this case, we're looking for cosine. Cosine theta. And cosine is adjacent over hypotenuse. Okay. In this case, I already know my hypotenuse, 21 square root 2, but I do not know the adjacent side. I got to figure that out. You have a right triangle, you know 2 sides out of 3. We're going to use Pythagorean theorem to figure this out. A squared plus b squared equals c squared becomes opposite squared plus adjacent squared equals hypotenuse squared. What do we know? We know our hypotenuse, 21 square root 2, got to square that. And we also know our opposite side is 21, so we'll have here a 21 squared. We don't know is our adjacent squared. I'm going to call that b. If we use our calculator, we can figure out that 21 squared is 441. As far as 21 root 2 squared, 21 root 2 squared would be 21 squared times root 2 squared, which is 441 times root 2 squared turns into square root of 4, which is just plain 2. And 441 times 2, 882. I need the b squared by itself. I'll subtract 1441. Subtract 1441. So now I have b squared equals, that's 441. 882 minus 441 gives me another 441. And I need the square root. And yes, again, I want you to show me that square root symbol. B squared equals, and the square root of 1441 is 21. That's actually not b squared anymore. That's now just b. Move that up to the top because that is our adjacent side we were looking for. We have another one of those fractions where we could do some reducing, and we have to get rid of the radical on the bottom. So I'm going to reduce this just a little bit by saying 21 goes in here once, 21 goes in here once, and I'm going to get rid of the radical on the bottom by saying multiply top and bottom both by root 2. I now have on the top 1 times root 2, which is just root 2. On the bottom I have root 2 times root 2, which is root 4, or plain 2, times comes that blue 1 over there. I don't need that. So cosine theta equals root 2 over 2. You'll find that that happens whenever your opposite and your adjacent turn out to be the same size. Number 4 asks us to find sine theta. Sine theta. And we know that sine is opposite over hypotenuse. So in this case, I'm dealing with the opposite over the hypotenuse. Let's take a look at our triangle and say theta is here. That makes 2 opposite to theta. Across my right angle is my C, my hypotenuse, and then the side that touches the theta angle but is not actually the hypotenuse, that is my adjacent side. Sine is the opposite over the hypotenuse, and my opposite side is 2. My hypotenuse, I don't know, and that's equal to sine theta. I'm going to have to figure out what exactly is the value of that C. So I'm going to think Pythagorean theorem, because I know 2 sides. Opposite side plus adjacent side equals hypotenuse. That's up there. I'm not going to bother to write out those words again. The opposite side is 2. The adjacent side is 4. And I'm trying to find the hypotenuse, call that C. So 2 squared is 4. 4 squared is 16. 4 plus 16, 20 equals C squared. And of course, we get C squared to change to a plain C by taking the square root. Okay, square root of 20, I need my 20. 20 is 5 times 4. 4 is 2 times 2. I have a pair of 2's, single 2. Left over 5, he stays inside, equals my C. That's my hypotenuse. Let's take out this letter C. I wouldn't have to write it if I saw it in the first place. And let's put in 2 square root of 5. And again, I don't like it if the fraction bar doesn't come all the way to the end, so we're putting it out there. I'm going to say I need to get rid of root 5. Multiply it on the top, multiply it on the bottom, and now have 2 square root 5 over 2 times root 5 times root 5 is just 5. Oh, I wish I'd noticed those 2's in the first place. That's okay. We'll reduce them now. 2 goes in there once, 2 goes in there once. I now have square root of 5 over plane 5. That's my answer for sine of theta. Okay, let's move on to another type of problem. In this next section, they have given us some sides. Number 6, they're not already on the triangle. You know, we don't even actually have to put them on a triangle if we don't want to. We know, because angle C is the right angle, we know that side C will be our hypotenuse. We know that side B and A, we need A. There's cosine of A, so we're going to be dealing with angle A. That means lowercase a is opposite, and that leaves adjacent for the 8. If you want to put them on the picture, you can do that. I'll probably do that on the next problem. So I need to find the missing side first. And of course, a squared plus b squared equals c squared leads me to unknown a. B is 8. And c is 8 square root 10. I need to square those things. Eight squared is 64. When I square this one, I'm going to square the 8 to give me 64. And I'm going to say root 10 times root 10. That's root 100, and the square root of 100 is just 10. So now I have a squared plus 64 equals 640. I need my a squared by itself, so I'm going to subtract 64 on both sides. Leave me with a squared equals 576. And I think that's a perfect square. Let's use the calculator to check that one out. Turns out a squared equals 24. If it didn't turn out to be a perfect square on my calculator, because the directions here say I need no decimal answers, I would have had to go back and do a factor tree like I was doing on those first problems. I'm trying to find the cosine of angle A. Cosine of A is the adjacent side over the hypotenuse. At this point, I do know all the sides. The adjacent side is 8. The hypotenuse is 24. No, the hypotenuse is 8 root 10. Make that 8 over 8 square root 10. This is one of those situations where I can reduce right here, but I also need to get rid of the root 10. Root 10 on top, root 10 on the bottom. Remember that when we multiply by root 10 over root 10, we're really just multiplying by 1. It makes the answer look different, but it still has the same value. So that I get cosine A equals 1 root 10 over root 10 times root 10, which is just plain 10. Up here, root 10 over 10. And again, if you are not printing out the worksheet, which you certainly don't have to, you need to be aware that there are two answers. Those two answers are A equals, notice I erased the 2 exponent that I accidentally had on there, and cosine A equals. Both of those answers need to be circled if you're submitting your assignment and you haven't printed it out to print those in the space. The next problem I want to look at is number 16. This time, just because some of you are better with it on the triangle, I think I'll write it on the triangle. We don't actually have the pieces of the triangle given. This is more like some of those ones that were towards the end of our notes today. So I want to find cosine theta given tangent theta. And tangent is opposite over adjacent. And I need to know cosine. Let me put what I know on my picture. I know my opposite side is 3 square root 10. And I know that my adjacent side is 20, but I need to find that hypotenuse. How do I know I need the hypotenuse? Because I'm trying to find the cosine of theta. And cosine is the adjacent side over the hypotenuse. In this case, I already know the adjacent side is 20. I need to figure out that hypotenuse. I'm going to use Pythagorean theorem and find the missing side again. A squared plus b squared equals c squared. Opposite squared plus adjacent squared equals hypotenuse squared. So 3 root 10 squared plus 20 squared equals c squared. 3 root 10 squared is really 3 squared times root 10 squared. I don't ever write that step down. But 3 squared is 9. Root 10 squared is 10. I usually show that step. Or you can put it in your calculator if you can figure out where to put all the parentheses in the right place. 9 times 10. This part turns out to be 90. plus 20 squared. 2 times 2 is 4, so 20 squared should be 400 equals c squared. So now I have 490 equals c squared. Let's take the square root on both sides. Again, show me that square root step. I need to split up my 490, see what I can get out of that. 490 has a 0 on the end, so I would assume 10 times 49. 10 becomes 2 times 5. 49 becomes 7 times 7. Pair of 7s gives me an outside 7. Left over 2, left over 5. So I have up here 7 square root 10. That's my c squared. It's not actually one of the things they asked for in the answer, so I'm not going to circle that. But I am going to say I need to know that hypotenuse. So on the bottom of this, I'm writing 7 square root 10. Can't leave the radical on the bottom. Let's see if I can squeeze some of this onto the side. I'm going to do square root 10, square root 10, so that now I have 20 square root 10 over 7 times root 10 times root 10 is plain 10. Before I even bother to multiply that out to my 70, let's reduce. 10 goes in there once, 10 goes in there twice. Now I have 2 square root 10 over 7. That is my answer for the cosine of theta. I was about to say I was finished with this section, but then I decided I have a lot of space left on this page. Maybe I'll just throw in one more. I didn't type it, but let's look at it. How about number 14? Number 14 says, find cosine theta if tangent theta equals 3/4. Okay, let's see. What do I know? I know tangent theta equals 3/4. And I want to know cosine theta. Cosine theta is always adjacent over hypotenuse, and tangent theta is opposite over adjacent. I know when I start working on my cosine theta, then I already know the adjacent one from over here is going to be 4, but I don't know my hypotenuse. So again, I'm going to think about my triangle. I haven't even drawn a triangle, but I know opposite squared plus adjacent squared equals hypotenuse squared. So 3 squared plus 4 squared equals c squared. 9 plus 16 equals c squared. 9 plus 16, 25 equals c squared. Square root of 25, square root of 25, c equals 5. And some of you are going to say, but I knew the 3, 4, 5 triangle. If you know the 3, 4, 5 triangle, I still want to see the setup and the answer here. And there may be other cases where you can do that too. But always, when you're using Pythagorean theorem, show me what numbers you plugged in. I don't want just this step. I want to know what numbers you plugged in and what number you got out of there. I prefer to see the square root step, especially if it's more complicated. But in this case, I could live with just first and last step. So I have my hypotenuse equals 5. I can come over here. Let me just take out the c. And I'm putting in a 5 instead. And there's nothing to reduce. There you go. Some of them are that simple. They have just nice whole numbers. Okay, I think that's enough of that type of problem. I will do another video that has some more solve the triangle problems from the back page.